Is there any alternative to do the same thing? I mean, almost the same thing without paying for all the resources we're using, okay? Any alternative? Do you guys know what that is? Based on your reading, yes. What are the alternatives? Yeah.
Just taking a guess, it's some kind of like third party.
Yeah. Third party?
Yeah.
Doing the encryption? Yeah. In this case, I mean, if you're talking about something like cloud computing, right? That's possible, but what this is referring to is really the organization having to send this message themselves. So third party cannot really do it for them. They have to do it pretty much. When you're sending an email, right? I mean, of course, you can send it to the third party and then they can send it on, but I mean, you're just introducing another layer of, I guess, bureaucracy. So I'm just looking for an answer that is lighter weight than using public-private key encryption. Based on your reading, so I'm not really asking anything out of the thin air. Yes?
Are you referring to HMAC?
Yes, correct. Yeah, correct. HMAC. What is HMAC? Do you guys remember?
What it stands for? I know what it stands for.
I know, but what does it do? Based on your reading. What was HMAC? It starts with, I think, K. Key hashed, right? Message authentication code. Message. I mean, there's a typo in the textbook. It's not supposed to be method there. Yeah, it has to be message authentication code. Yeah. So there's a typo in the textbook actually. Yeah. Message authentication, not method. Yeah. But anyway, before we talk about that, okay, for us to be able to use the certificate authority to issue the certificate, all those things, right? We need something called PKI infrastructure, because part of the infrastructure is really the certificate authority issuing the certificates, right? So it's not just the organization and then the receiver of the certificates. You have to have this third party issuing the certificates, right? So that's why it's called the PKI infrastructure. So in this case, PKI stands for? No. PKI?
Public key.
Yeah. So public key infrastructure, yes. PKI, yes. And what does it involve? The third party, the certificate authority, right? It involves the organization that needs the certificate, right? It also involves the user of the certificates and all those, pretty much. Okay? Yeah. So now we can talk about HMAC, okay? So any volunteer who can show me how HMAC works? Has it been too long since you did your reading? Cooper?
No, it's definitely been too long.
Okay, yeah, very good. So since the exam's around the corner, you have to remember this, okay, how this works. So let me go over it once and let's see if you can do this on your own, okay? So key hashed message authentication code, HMAC. So this is a lighter weight way of doing basically message by message authentication and the integrity check. So it accomplishes both message by message authentication and then also the integrity check, okay? So like I said, it's a cheaper alternative in terms of the use of the CPU and the use of the memory, okay? How does that work? So no asymmetric key encryptions involved in this case, okay? No asymmetric key encryptions involved in this case. Only hashing is involved when we do this, okay? Only hashing's involved. And like I said, uses hashing and a common key. That's all it takes. So you don't need to have your key pair, public-private key, that type of thing, right? The assumptions in this case is there is this pre-shared key. So before you start your message by message authentication and integrity check, you have to have this shared key. Just like symmetric key encryption, you have to have this common key shared, right, between the two parties, right? So same idea. You have to have a pre-shared key to make this work, okay? So let's see if you can do this. So this is a good way of getting ready for the exam right now, because I mean you learn it now, you don't have to try to understand it on your own while you're reading the textbook, getting ready. Okay, so let's see. So this is how it works. So you have a message, and this has a lot of similarity to what was happening with MS Chap. Do you guys remember what that was about, MS Chap, right? When you were exchanging your password, right, with the server, right? You weren't just sending the plain text password, right? You had to what? You had to get a random value, you had to combine the random value with the password, you had to hash the value, right? And then send the hash value, right? So that was MS Chap. So that's sort of similar to this, but don't get confused because these are different. The purpose is different, but very similar actually. So you have a message, right? You start with a message you want to send, and to this you want to do the authentication and then the integrity check. And remember we have this pre-shared key, right? Already, right? We already shared this key. So what I'm doing is I'm going to add that key to the message, and then I get what? The hash value. Okay, the hash value of this combined string, the key and the original message. So that hash value is called key hashed message authentication code. Okay, does it make, I mean there's nothing difficult about this, right? No? Now, when you send the message, you send the message together with this HMAC, key hashed message authentication code together. That's what you're sending. So on the receiving side, what do you think they're doing then? Yeah, I know they're verifying, but how do they verify? That's the next question.
Do you have the key on your side as well?
So they already have the key, yeah, because it's a pre-shared key, right? So what would they be doing then? Yeah. Yes.
With the original message.
Yeah. What? Say that again.
They find the hash value with the original message plus the key, and then verify it to the HMAC.
Okay. Yeah. So that's right. Is that what you were going to say? So this is what's happening, right? So this is what you received, which is actually this part of the message you just received. So transmitted text, right? And then now you apply the key, because you already have the key, right? To that. You combine them. Can you get the same HMAC out of that? Right? Yes? You can compute your own HMAC, right? So you compute your own HMAC, and then what? Can you compare this thing and then that thing, right? If they match, then what? Nothing changes, right? Is that right? Because since the only person who owns the key is you and your partner, right? That kind of authenticates, right, the partner, because nobody else could have had the key, right? But we still run into the same issue here, because if that key is compromised, then you cannot prove anything, basically.